Welcome back to Let's Code. I'm Chris Biscardi, and today we're going to dive into the Rust compiler. Now, this will be the first time I've ever compiled the Rust compiler, so we need to go to the rustc dev guide to figure out what we actually have to do. The URL is rustcdevguide.rustlang.org, but if you can't find it, you can just search for rustc dev guide in Google, and it should pop up as the first result. Now, this guide gives a lot of information about rustc and how it works, but specifically today, we're going to go on the homepage about this guide and go directly to the building and debugging rustc section. This drops us onto a huge page. Just from the table of contents, we can kind of see there's a lot going on here. This isn't something that you just git clone and then cargo build. This requires you to have a number of things previously installed. There are build scripts in, I believe, x.py. That's why there's a whole intro to x.py and what it does. And then we get into actually building and testing things like rustc or rustdoc or running any of the tests or anything else. There's also a whole section on contributor procedures that I'm actually going to push off to a different video. I do plan on making an actual contribution to the Rust compiler, so we will have to go actually find an issue. We'll work through it together, and then I will cover this at that point. Now, the documentation isn't comprehensive, so I believe one of the places that you can ask questions is in the Rustlang Zulip. The compiler team, or T-compiler, usually hangs out in Zulip in this stream. That looks like the T-compiler stream, which is here. I assume it's T-compiler help. I have a hard time navigating Zulip myself, but the more time you spend with it, the more you start to get used to what is actually here and how this actually works. It's basically like a whole ton of threads. So imagine if Discord or Slack only lets you start threads, and that's basically how Zulip works. One thing to mention is that rustc is very big and that nobody has the full compiler in their head at all times. So if you're asking questions, there's this map in the Rustlang compiler team repo under content experts map.toml, and it gives you kind of who's an expert in that area. You can see that rustc is a fairly large, complicated project, and as such, often only has, say, 2 people who are experts in any given subsystem. This is often the people who have worked on it the most. So the main repository is Rustlang Rust. We will need to use that. This contains the compiler, the standard library actually being basically a crate, and a bunch of tools like rustdoc. There are a bunch of submodules for things like Llvm, Clippy, and Miri. Miri being an intermediate representation, I believe. Let's go look up what Miri is. Miri Rust. Miri is actually an interpreter for a intermediate representation of Rust. So Rust, when it compiles, has actual multiple intermediate representations between the source code that you actually write and the end result machine code that you actually run. MIR is one of those representations. I believe there's also HIR, and I don't know that I know the other one, so we'll figure that out as we go. It's also worth going over Llvm very shortly. Okay, we're going to Google Llvm and leave it here because the next page is actually just a bright white page, and if you're watching this and you don't expect it, like I just did, it will, it will be a pretty rough transition. So Llvm is basically like the thing all languages target to compile to machine code. It's kind of like a compiler library, if you want to think about it like that. It's basically a piece of infrastructure that a bunch of languages can target, languages like C or Rust, or even like one of your own toy languages, so that you don't have to write all of the little pieces that are finicky on every architecture for every machine and that kind of thing. So Llvm, super useful. Also a very large separate project that we won't actually get into, but Rust does depend on it to do its code generation. So it's nice to know what it is. There's a suggested workflows chapter. I don't think that we will go into that just now. System requirements. You will need Python 2 or 3 to run x.py. Let's figure out what I have. So I'm not going to use, well, I wonder if I can use new shell for this. Let's start going with new shell, and if it doesn't work, then we will backtrack. It looks like I have Python 3.8.6, so I think that's okay. Make this quite a bit bigger so we can see it. I'm actually in a Python terminal. How do I get out of a Python shell? Control Z plus return. Okay, there we go. So we are back in here, and we will configuring Rust Analyzer for rustc sounds like something we will want. You will need Python 2 or 3 to run x.py. We have Python 3, so we're not worried about it. Building the compiler is computationally expensive, so a beefier machine will help. That's why I'm doing this on Windows. You'll notice that the setup that I'm using today is slightly different than my other videos. That is because my Windows machine has access to a Threadripper, which is quite a beefy CPU. We also need 30 gigs of free disk space. I believe that I have plenty. Let's find out. System information. You can see the Threadripper here. Hardware, resources, memory. Memory? No, that's RAM. Storage drives. I have about 300 gigs of free space on my computer, so we are good. Recommended greater than 8 gigs of RAM. I know I have more than 8 gigs of RAM. Recommended more than 2 cores. I have a lot of cores because of the Threadripper. Having more cores really helps. So apparently this is something that benefits from having more cores. You'll need an internet connection to build. Involves updating Git submodules and downloading a beta compiler. It doesn't need to be super fast. So the internet connection doesn't need to be fast, but the CPU should be as fast as possible. Building the compiler takes more than half an hour on my moderately powerful laptop. Let's see if we can get lower than half an hour. The first time you build, Llvm will also be built unless you use the CI built Llvm. I think we can also just build Llvm. Like Cargo, the build system will use as many cores as possible. Sometimes this can cause you to run low on memory. I have quite a bit of memory. I have 64 gigs. It's not as much as I can put in this machine. So if I start running into some problems, I'll probably upgrade to 128 or something like that. I think Threadripper can handle, and my motherboard can handle 128. You can use J to adjust the number of concurrent jobs. If a full build takes more than 45 minutes to an hour, you're probably spending most of the time swapping memory. Interesting. On a slow machine, the build times for rustc are very painful. Yeah, I mean, half-hour builds are nothing to shake a stick at, as it were. Consider using x.py check instead. So x.py check, I believe, would run the equivalent of like a cargo check, and then letting basically the automated tests run on GitHub instead of running them locally. Then great. You don't have too much free disk space. We have 10 times the amount of recommended disk space, so we are good. But you can also turn off incremental compilation. It's like, this will take longer after a rebase. And I'm just imagining like half-hour builds after a rebase. That would feel awful. Okay, so we can just do a normal Git clone. I do not know why new shell isn't picking up the latest version. I will figure that out some other time. So let me go into GitHub and I will make dir, what's the org? It's rust-lang. Make dir rustlang. Oh, my auto-completes to Rust Adventure, which makes some sense because I do a bunch of work making sure my workshops for Rust Adventure can work on Windows. Let's see, Rustlang, and then we'll git clone. Actually, I already have that whole thing, right? Paste anyway. Cool. So we're cloning Rustlang. It seems like it's pretty big. Usually things don't take this long to clone for me. We will need to do a submodule update after this. So you don't need to clone the submodules at this time, but if you want to, you can do the following. I think that the build process said they were going to do this for us, so maybe we'll let the build process do it for us. The compiler has a configuration file which contains a ton of settings. We will provide some recommendations here that should work for most, but check out this chapter for more info. I really don't like that this keeps popping up every time I go anywhere near the top. In the top level of the repo, run x.py setup. Okay, this was create a config.toml. That opened here. Okay, x.py setup. It's the same thing that has us running here, so I guess we'll just, yeah, okay. So we don't actually need to create a config.toml. We will provide some recommendations here that should work from us. So this will just create the config.toml for us. x.py creates it. So let's grab this and let's get back over to here and let's get into the Rust repo. They're still using a master branch, which is interesting because it's hard to move large projects. Git branch. Let's see what else they have. I have -a. So beta stable yeet unused substas. I don't know what a sub-STS is. Substas. But that's interesting. Little crane lift stuff in here. Crane lift is interesting if you haven't looked at it. Okay, not really interesting. So let's do x.py setup. x.py setup. That opened VS Code for me. So if you're interested in seeing what x.py actually is, it looks like it's just import OS, import sys, check for the latest Python version. It looks like it wants to prefer Python 3. Well, that's cool. And then it just runs Bootstrap from somewhere else. Maybe we've found what will end up being our first contribution. I'm starting to be convinced that this is not actually a shell problem. This is a me problem. Do I need to like Python .py setup? Okay, so I needed to write python.exe x.py setup. I will make a note of that, I suppose. Where's my open a new notepad? Why not? Actually, I don't know. Not Notepad. Notion. There we go. I'll use Notion now. So I'm not actually sure what this is doing. It is compiling quite a bit. Let's take a look at some of the logs. Looks like we've updated all of the submodules, which we were told this was going to do. So that's good. Extracting some tars, Rust format nightly. So it's pulling down a beta compiler, which we were also told it was going to do. It looks like setup has completed, or at least gotten us to a point where we should be at, according to the documentation we see here. Let's move this left and this right. Okay, so welcome to the Rust project. What do you want to do with x.py? Contribute to the standard library, contribute to the compiler itself, contribute to the compiler, and also modify LLVM or CodeGen. I probably don't want to get into modifying LLVM yet, so I'm probably going to choose compiler. It looks like they have us choosing A, so library, contribute to the standard library. So I'm going to stick with, what am I going to do? All right, let's find a little bit more out about rustc and what that means, and then we can make a choice here. I think I'm going to choose B just because I want to. Rustc is a bootstrapping compiler, which means that it is written in Rust and thus needs to be compiled by itself. So Rust is written in Rust. So where do you get the original compiler from? We use the current beta compiler to build the new compiler. So then we use that compiler to build itself. Okay, so they use the current beta compiler, so the nightly build, which is just available, to build a new compiler. Then we use the new compiler to build a copy of itself. I guess that's to check to make sure the new compiler can actually compile itself, like just a sanity check right away. Then we use that command. Thus, rustc is a two-stage build. Stage one being nightly to current, and then current to current. You can read more about bootstrapping here. But we don't really need to read about bootstrapping today. We're just trying to get through a compilation. X.py drives the process. We've already seen X.py. Unfortunately, a proper two-stage build takes a long time depending on hardware. We know this from earlier in this document, actually. But it is the only correct way to build everything. It's what CI and release use. However, in most cases, you can get by without the full two-stage build. Okay, so locally, we probably won't actually do the full two-stage build. In the following sections, we give instructions for how to do the correct thing, but then we also give various tips to speed things up. I don't think I'm going to speed things up just yet. I think I'm just going to do everything kind of the slow way. XPy check. If we set up Rust Analyzer, it'll just run check for us. That's cool. Build only the standard library without bundling the compiler. Build just the first stage of the compiler along with the standard library. This is usually good enough. Build the first stage of the compiler and skips rebuilding the standard library. This is useful for second builds. Runs the test suite, full two-stage build, full two-stage build. Okay, so I actually, from reading this document, I do not know what these options are going to do. And that makes me a little bit nervous. So we've got more x.build, x.py tests, gives us some Rust format commands, Rust log commands for logging stuff out. This is for building and testing various pieces, so Rust doc and other things. Okay, and then we're into the contributor procedures. So we just have to choose one and kind of guess. So I do want to contribute to the compiler. That is my goal. I assume that if I build the compiler, the standard library also gets built. Maybe? I don't know. So we're going to choose B. What did B run? B ran failed to link stage one build to stage one toolchain. To manually link stage one, run this. Rust CI will automatically fail if it doesn't pass Tidy, the internal tool for ensuring build quality. If you'd like, x.py can install a Git Hook for you that will automatically run tidy bless on each commit to ensure your code is up to par. So yeah, we'll install the Git Hook. I'm not sure. It says just run x.py build, right? So it did a couple of things for us here. And I really think they should explain the options here. Maybe I'll make a note of that. X.py setup could use an explanation of the options or what it does. So retroactively, I understand that x.py setup creates this TOML file, but I don't know what these things do. And all of the rest of the things that they talk about are low level, like intro to x.py immediately. So like you just set this up and then you're done. So let's take a look at TOML. Open config TOML, changelog scene 2 profile compiler. So shrug, don't know what that means yet. Profile compiler, that probably says profile library. if we chose option A. Let's see this. Maybe we do check first because it's the fastest. This will build the standard library. This is the first stage of the compiler. Building the first stage of the compiler, it skips rebuilding the standard library. One of these said this is usually good enough, right? This is usually good enough. Okay, we're going to do this. The first stage of the compiler and the standard library. So x.py build library standard. Right, because we learned that we have to run Python x.py build library standard. That's kind of annoying. I wonder why that is. Now we can see, let's see, updating submodules, nothing to update. This looks like it downloaded the Rust nightly compiler again and extracted it and is now building. So let's see how long this takes. Just for kicks, here's a representation of what's happening on the CPU at the moment. So we've got 16 cores to work with. It's kind of a last generation Threadripper, but is still quite powerful, using 100% of the CPU continuously. Now the memory keeps climbing and the CPU has been at 100% now for quite a while. Now I am also running OBS on this machine, so I believe that's why we see some GPU activity, but I would attribute most of everything to the Rust compilation that's happening, especially on the CPU. Unfortunately, our build failed. You can see the CPU dropped all the way down. 5 unresolved externals. So that's linking. I wonder if we can go and figure out... So there is an absolute ton of linker errors here. Why? I don't know. Try updating your linker. How do I update a linker on a Windows machine? No default lib. This is from 147. There are a ton of these too. Creating library, stage 0 rustc. So we basically have a linker error. It's got to be a setup issue for me. It's got to be an environment issue. So I need to figure out what that is. I'll have to figure this out. I'll have to update maybe my VS Code dev tools. Let's go back to how to build the compiler. This is the prerequisites. Okay, Python, curl, git, SSL, which comes with libssl dev. I definitely have stuff like that. Package config, G++, Clang++, Ninja, CMake, Windows, install Winget. So I don't think Winget. I do have Winget. So Winget install Python. We already have Python. I'm just going to make sure that it is installed, and it's a linker error. So what is going on here? No store account found. Okay, Winget install CMake. My guess is we don't have CMake installed or something like that, because that's the only place I can think of the linker coming from. All right, so that ran. That's about all I can say for that. Let's see if that changes our result. Okay, this is about when we would expect the linker error, right after this building phase. Nope, still got the linker error. It is possible that I just don't know how to develop on Windows enough. For more information about building on Windows, look at this. Okay, there are 2 prominent ABIs in use on Windows, MSVC and GNU. Which version of Rust you need largely depends on which C libraries you want to interoperate with. Grab the latest installer and install it, hoping this works, because I don't know what this is. Okay, that gives us a shell, interestingly enough. Go back from this terminal, install the required tools. Okay, so here we install Pacman, or not Pacman, we install, actually, I don't know what this does in Pacman. Update the mirrors, update the packages that are available, probably. Well, let's make this bigger. We'll proceed with the installation, and then we need all of this stuff. So basically, seeing CMake and GCC and Ninja in here makes me think that this is just going to be the shell that I use to build Rust on Windows. I kind of thought that because it was a Python script to bootstrap everything, that I was just going to be able to use whatever shell because it would be, you know, running in a proper language and whatnot. But I don't seem to have set up any of my other environments correctly. So msys2 is the shell we are going to use, or I guess it's the Ming W64 shell. I don't know. I don't do a lot of development on Windows, and I've never needed to do this before, but it's telling me that this will work. All right, so we've installed all the dependencies that we need. Let's see if we can get back to x.py build. Is it library standard? Go back. It is library standard. No such, oh, because I'm not in the right directory. That's what happens. I don't know where this put us. It is apparently not on my desktop. Home Chris. So this is just in a completely different, all right, let's do GitHub. We'll go into GitHub and we will make a Rustlang in here. So inside of this environment, we will have a Rustlang. And then we will go back and we'll actually clone the repo, which I need to make small before I grab the link because GitHub removes functionality when you make things bigger. So git clone, did I not paste it? So pasting into here is a little bit awkward. It doesn't have access to any of my stuff. So I'm going to have to git clone. And then manual shift insert is paste here. All right. After this video, I am definitely going to need to, dang, I don't even know where this is going to be on my system. This git clone is taking quite a bit longer than the git clone took before. So I'm a little concerned that this is restricted in some way. If we look at the CPU, it's not really using anything. So I'm not sure why this is taking so long. For those of you that watch the channel regularly, you'll know that Windows is not my home platform. So this has definitely been a bit of a ride. I usually do all of my Rust work and all of my work in general on Mac OS, except for video editing. So it's possible that all I need to do is get more used to a regular Windows development environment, and then I wouldn't be running into as many issues. But at about this point, it's been about an hour since I started getting into the compiler, and I still don't have a successful build. All right, with everything downloaded, I believe that we can now just run x.py build library standard. If we were in the right directory, we would be able to do that. x.py setup Python, no such file or directory. Didn't we just install Python? These instructions don't work for me. So maybe echo path and we'll see. I don't even know where these get put in this shell. So, okay. I've installed it and I literally cannot find it. Where is this running from? Okay, so I do ls msys64 is right here. So I guess 64 it's not recognized. I can't cd into it. Oh, I can cd into it. Okay, there we go. Okay, so we open the new Ming W64 shell and then we have Python available. Let's bring this back up. Let's close this one out. So basically we installed MSys stuff, we installed a bunch of things. We needed to then reopen the shell environment because apparently it didn't pick up what we just installed. I don't know if that's a path issue. I don't know what that is, but you do need to reopen MSys. So let's do cd github rust and then x.py setup, and hopefully this will do the submodules and give us the prompt that we had before. Okay, so we got the prompt that we got before. We are going to choose option B again and set up for the compiler build. I chose and I hit enter and it didn't work. So I'm not sure what to do here. Maybe this is a min TTY thing. So I think the program that is running the mysys or msys shell is min TTY. Maybe it doesn't interact well with prompts like this. Maybe if we opened it in Windows Terminal, we'll get a better result. Let's add a new profile, duplicate the new shell profile. Rust development is what I'll call this. Command line c:/msys64. Was it wing? Wing. This is a tab, so when is this? It won't even let me copy. Oh my. Oh, it did let me copy. Okay, let's do that. Is that the right directory? msys64, msys64. Okay, that looks okay. We'll hit okay. We'll pull up Rust development. Oh, nope, that runs the TTY no matter what. I don't know what to do about this now. X.py setup, choose B. Okay, it worked that time. I don't know why it didn't work before. Would you like to install the Git Hook? Yes. All right, let's get rid of this. Let's get rid of that. I don't know why that caused a problem, but let's blow this back up. We'll put this here. We'll put, I don't know, let's put this over here. So x.py build library standard, enter. And now we wait again for it to redo everything. I started at 2:05 a.m. and we are successfully building once again. Full CPU usage. All right, and now we are done. I think we have a build. It took us 8 minutes and 21 seconds. I don't know how to test this now. Let's keep going. Build, okay, build and keep. 8 minutes is not that long. I think that I will just keep going with that for now. Bunch of tests. Can I compile a Rust program with it is my big question right now. I guess we didn't build stage 2, so we can't. Building and testing Rust doc. Can I open this in VS Code even? The VS Code CLI is not found inside of this environment. So I do not know how I'm going to get to wherever this is. Let's try Windows Terminal. Let's pull open new shell. I don't even know. Let's cd into, that's not where I meant. So we're in C. We can go into msys64. This looks like a file system, like a Linux file system. So there's etc, there's home, there's dir, there's temp. Maybe the entire file system is just in here. In that case, what? User, no. Home Chris GitHub. So home Chris GitHub, Rustlang, Rust. Starship is really interested in running some commands on this. So it did. Looks like it took a little bit too long because this is quite a large repo. So maybe I'll have to disable some Starship stuff inside of this. I have most of these disabled on my Mac, but let's see. So if I do code dot here, that'll open the Rust files. Where's the Rust Analyzer stuff? Let's set up Rust Analyzer. Or let's see actually if Rust Analyzer can be set up on a Windows machine, I guess. So if I open this, I get Rust, I suppose, 15 submodules, which won't be open automatically. That makes total sense to me. There are quite a bit of files here. Let's see, source, CI, compiler. So library std is actually a directory in here. So we just built this, I guess. So we've got fs, we've got only tests in here. Interesting. Where's fs? Okay, we're gonna have to do a completely separate walkthrough and like a discovery of this repo because there's a lot. As far as I can tell. Let's pull this down a little bit. So this will be a little hard to see, but these are FS tests, I suppose. Got config Windows, config Mac OS, macro rules for check and error. Several tests fail on Windows if the user does not have permission to create symlinks. Okay, got symlink permission, bunch of stuff for Mac OS. This is a test, file test, IO smoke test. So we create a message, we create a temp directory, join the temp directory with fake file name path, create a write stream inside of its own block that creates the file, and then we write the message as bytes and we check whatever the check macro does. I assume that the check macro makes sure that all of these things that potentially return results succeed. That would be my guess. Let's go check. See the check macro, if okay, then fine, and if error, then T. So this is just a basic match on any expression. I think this is called a TT muncher. I don't know enough about macros to say that for sure, but this is basically defining a macro called check that operates on any expression. So we take E, which is the expression, we match on E. In this case, E would be like file.whatever. I'm not going to change that because it'll break things. But if that returns a result that has an OK variant, then we return the value. If it has a result that is an error variant, then we panic. And it says the thing that we got. So I guess the expression is, we stringify the expression using this macro, which I would guess is defined somewhere else. That seems pretty common utility level. Otherwise, we just print out the error. So that is what the check macro does. Then we create a read stream by opening the file using the check macro again. So check macro panics if this is an error. So everything is hard pass here. The read buffer, so the message is only 1028 bytes. Again, we match on reading the stream. Interestingly, we match on check. Okay, so read is a result. We check. And then I wonder what comes. Readstream.read must bring back the number of bytes. That seems right. That seems like what we're getting here. So because 0 shouldn't happen because we wrote a message to the file, and then n would happen, and we try to read from the byte slice. We unwrap. Interesting that we don't use check here. We use unwrap, even though we use check everywhere else. I guess that, I don't know. I don't know why we use check everywhere else and we use unwrap here. Maybe it's because we have to toString on the end. But we basically take the byte slice and we convert it to a string, standard string UTF-8. No, we're not using standard here. I wonder if that's already in scope or, So crate reaches to the entry point of the crate. Standard library is basically just another library that you can use because you can use Rust with no standard. So we're using std string to create a string from a slice of U8s, basically. And then we do an assert. Okay. And then we remove the file at the end. So this seems pretty readable, actually. I think that There is a lot of code here. This looks like code for every system. There's FS, there's Mac OS. So that must be where, okay, so the FS stuff is operating system dependent. So in Mac OS, this must have like read and stuff like that defined. Let's see if we can find read. Not in here. Maybe it's somewhere else. I don't know. We'll look into it more later. But we have a compiling compiler, as it were, which is a step further than we were before. So if you try to build rustc on Windows, I hope this helps a little bit. I hope that the issues that I've run into are issues that you can avoid. And we have a built-in compiler now. So that's super exciting. And we get to start diving into the actual rustc code and maybe playing with stuff and changing it and seeing where it breaks. So I will see you in the next episode.